Attention, salience, and the primary visual cortex. Part 1. Attention and information bottleneck. Attentional selection is the second of the three visual stages: encoding, selection, and decoding. Encoding is to sample visual inputs and to represent the inputs in neural responses. Selection is to select a small fraction of the inputs for further processing, and this is called attentional selection, and this stage can also be called looking in layman's terms. Decoding is then the seeing after the looking, to infer or recognize the visual scene properties, such as to recognize a face from the selected inputs. So therefore, attentional selection is very important since it gates our visual perception.
The reason we need selection is because there's information bottlenecks in the visual pathway. Visual input data is about 25 megabytes per second, coming from about 25 images per second, received by millions of photoreceptors on our retina. This amount of data can contain the text in dozens of books. Retina can compress this data to about the amount for one book. This is still too much for us to read in 1 second. How much can we read in a second? Our attention can read about 2 sentences per second, or this equivalent amount of visual information. This means more than 99% of the information is ignored or deleted. Only a tiny fraction is selected by our attention, so we are blind to the non-selected part. This does not seem to agree with our impression, since we feel that we can see everything in front of us clearly. This is because we do not know what we do not see.
Here is a demonstration of our blindness. Can you see the difference between these two images? The difference is quite big, so if you are not blind, you should see it immediately. Most people cannot see it immediately within 10 seconds. Here they are. These two portions are very different from each other. Therefore, we are blind to almost everything in front of us, except the tiny bit that we pay attention to. And therefore, we have this flow diagram of visual information, a massive amount of visual inputs, of which only a tiny fraction can be admitted into the attentional bottleneck for recognition. The size of this bottleneck was measured decades ago, and this was one such experiment. Human observers were told that they would be shown one of these 16 symbols in an image, shown very, very briefly, and then they had to report which symbol was shown. If the image containing a single symbol was shown for only 1/15 of a second, most observers could not correctly report which symbol was shown. Note that to pin down 1 out of 16 possibilities, 4 bits of information is required. Therefore, 4 bits in 1/15 of a second was too much for this bottleneck. However, if the image was shown for twice as long, so 2/15 of a second, then most people can see the symbol correctly. Now, if the observers were told and knew ahead of time that the symbol could only be 1 out of 2 possibilities, then flashing the image for only 1/30 of a second was enough for them to report the symbol correctly. Note that to pin down 1 out of 2 possibilities, only 1 bit of information is required. Combining these observations together, the bottleneck is roughly between 30 to 60 bits per second. Similar values for this bottleneck were obtained by other experiments.